By the end of this video, you will be able to describe and contrast the lithosphere and asthenosphere and the function of each. You will be able to contrast the motion of the different types of plate boundaries, and you will be able to identify a characteristic feature located at or produced by the different types of plate boundaries. All right, so today we're here to talk about the interactions of plates and what happens at plate boundaries. And we're going to use a Milky Way candy bar to help us, which will serve as an analog for those interactions and the different types of plate boundaries and the features that we find at tectonic plate boundaries. So, a Milky Way. Have you all had Milky Ways before at some time? Yeah, I'm sure you have many, right? So, a Milky Way bar. So, what is a Milky Way bar made of? What do we have here?
Yeah, the chocolate.
We have the chocolate. And what's underneath the chocolate, Erica? Do you remember?
The caramel nougat?
Yeah, the caramel nougat's underneath. So the caramel and chocolate nougat are very much like Earth's layers, which the chocolate, which is very hard and brittle, would be like which of Earth's layers, tectonic layers?
The lithosphere?
The lithosphere, right. And the caramel, which is kind of soft and gooey, would be more like what, Jeff?
The asthenosphere?
The asthenosphere, right. So we have the chocolate being the lithosphere, the caramel nougat underneath being the asthenosphere. And the asthenosphere is soft and gooey, well, the caramel is, but the asthenosphere is more like what, Andrew?
Sort of magma?
Yeah, like magma, molten rock. So very hot, a much hotter place. And the lithosphere, the chocolate, is kind of cold and rigid and brittle. So what we're going to do to demonstrate tectonic plate motions is we're going to take our fingernails from our thumb or forefinger, index finger, and make some cracks along the top. We have to operate pretty quickly because our body temperatures are going to make this candy bar melt on its own. So now that we have the chocolate pieces on the top, so what do all those different pieces of chocolate represent, Erica?
Plate boundaries?
Yeah, the plate boundaries. These are all, the chocolate pieces are the lithospheric plates, and all the separations, the cracks, are the boundaries. So we are going to now manipulate our Milky Way bar, and we're going to slowly pull it apart. And when we say plates are moving apart, like we're moving them apart now, we say they are diverging. So, with diverging plates, like this pulling apart motion, what do you see in between the plate boundaries, Andrew?
You see the layer underneath it.
Yeah, you see the layer underneath it. Remember, that's the asthenosphere, the molten rock, the magma underneath. So now we have space for that magma to come up between that spaces. So what might you find at diverging plate boundaries when you think of magma rising to the surface, Jeff?
Volcanoes.
Yeah, you see volcanoes. So volcanic activity is an important feature at diverging plate boundaries. The divergence allows the magma to come up and form volcanoes and volcanic activity. So that's divergence. Now we're going to push these pieces back together again. And I'm having a little trouble. It doesn't go back to the same position. What did some of your chocolate pieces? Yeah, yours looks like mine, Erica.
Yeah.
How about yours? Oh yeah, yours looks different. Yours, yeah, you could get a little more intense with your with your pushing together again. But pushing together, plates moving back together again, isn't divergence. Now we have convergent plate boundaries, and so the overriding chocolate pieces and they're just kind of smashing into one another. What probably forms when you have convergent plate boundaries?
Mountain belts?
Yeah, you would see mountain belts like the Himalayas in Asia, the Appalachians in eastern North America, right here running through Pennsylvania. So that's convergent. So with convergent plate boundaries, we expect mountains to form from the overriding plates. My candy bar doesn't look anything like it originally did. Yours doesn't either, yeah. Let's do for one more pull apart, get more divergence. Got to be careful, otherwise the whole thing's going to fall apart. And there's divergence. We have opening for the asthenosphere to rise. The caramel is exposed, and the asthenosphere could rise and have volcanic activity. And now we push it back together again. The chocolate pieces are smashing into one another. And when chocolate pieces smash into one another, we get mountain belts. And how does your candy bar, oh, you really have a lot of, it really looks a lot different, right? So what does that tell us about Earth's tectonics plates over time, that after millions of years, does it look anything like it originally did, Andrew?
No,
Yeah, yeah. So even after 2 or 3 pull-aparts and push-togethers, the candy bar doesn't look anything like the original bar that came out of the package, just like Earth doesn't look the same as it did 200 million years ago, 500 million years ago, a billion years ago. Earth's tectonic activity changes the appearance of Earth, whether the plates are diverging or coming apart, or they're converging, coming back together. So what might you feel at a plate boundary every now and then to remind you that you're at a plate boundary? Andrew, what do you think?
Earthquakes?
Probably earthquakes. It's a pretty stressful place to be at a plate boundary. Either something's pulling apart from you, or something's smashing into you, or rubbing up against you. That's just really not an easy place to be when you're a tectonic plate. And so earthquakes are very common at plate tectonic boundaries. So the next time you're in the supermarket and you see all those candy bars, remember that Milky Ways are great analogies for lithosphere and asthenosphere for representing plate tectonic motion and what happens at certain types of plate boundaries. And if you don't like candy, then go to the cheese section and get some brie cheese, where that rind would be the lithosphere and the cheese, the soft gooey part underneath, would be the asthenosphere, for those of you that like cheese. Now I'm hungry and I want some cheese. Time to go to the supermarket.
When you have finished watching the video, you'll be taking a short questionnaire that will ask you to rate your confidence on a scale from 0 to 10 in performing all of the learning objectives, where 0 is not confident or sure you can do any of the objectives, 5 is fairly confident or sure you can do some of the objectives, and 10 is very confident or sure you can do all of the objectives.